Wait, is it working?
Well,
Oh, here we go.
I can tell that you were having a giggle talking to me because you were looking at me. Don't was
Sorry, what was
Yeah, sorry.
No, it's so good. Basically, I want to figure out what you're up to. Just in terms of have you watched the lectures?
I watched the first one and I gave up.
Oh, okay.
I've spoken to you multiple times on the phone.
On site. Spoken to the Transport New South Wales officer on site. Okay, well, basically, here were the week one contents. General topics, right? And then week 2 actually went really fast. And this is quite a bit. They covered 2 topics in 1 week because they want to get to the mechanical properties.
I heard they delayed it last year, right?
I think since I was part of Prash's tute, he accelerated us. So we got onto the mechanical properties, but I can't speak for other tutes, they might have happened, so yeah. Are you guys in Prash's class?
No.
Lucky. I know your guy's pretty decent.
It's actually okay, yeah.
What about your workshop?
Karen.
Are they okay?
Yeah, Karen.
Is she okay?
He's okay.
Okay. Because I'm trying to figure out how fast I should go.
He goes too quickly. Like I can't. Like I feel like my complaint is that he goes too quickly. I couldn't write down anything.
Oh.
Yeah.
So you guys have all done 201, right? That's a big part of this first part of the course.
What's 2101?
Construction.
Yeah.
It's the one you said you did well in.
Yeah, I don't know.
Born to be a trippy beaver. Yeah. I'll let you copy these down. There's not much to write here. But these are based on the names of the lecture files, right? I've also got these in my concrete Google Drive folder. So if you miss it, then you can put it down. So that production's a little bit different.
Why is it CAB? Is there a reason for that?
Where are you looking to?
Free C, free A, free B.
Oh, sorry, my bad. So basically, I'm gonna teach you 3C before 3A and 3B because it makes more sense in my head because it's like
add mixtures before you fucking pour it.
no, because they basically tell you about the ingredients of concrete in this kind of area, right?
Yeah.
And then 3C is kind of more related to the ingredients of concrete. It's like an optional ingredient, right?
Yeah.
But then fresh concrete is about like 2101 site processes. And 3B is actually something basically completely new. It starts going towards mechanics of solids, right? So I think it just makes more sense to order it this way because this is all material science. Okay. So 1A is cement production, right? So basically, it's listed here, but the ingredients in concrete, you've got your cement, water, and ag, right? Aggregate made up of coarse and fine aggregates. It's like baking a cake, right? So concrete is like a cake, and then this is like your egg, water, or which would be like milk or something, I don't know. And then aggregate might be like flour, something. These are all just basic ingredients in a cake. And there's different ways to bake a cake, and then when we talk about admixtures later, they'll be like vanilla extract or these kind of fancy advanced techniques or ingredients that you can add into a cake, right? The cake analogy will kind of run as we keep talking about it. There's actually a few ways we can compare concrete to making a cake. So it's quite interesting. I've just included the rough volume of things. So the aggregate will make up the majority of the volume in concrete, right? If you look at concrete, you'll see a lot of the rock particles. That's just the volume, right, that you can see. Because cement, if you think about it, cement will be the most expensive ingredient in concrete, right? So if you want to save costs for making concrete, you want to think about how we can reduce that most expensive ingredient, right? I'll talk about that in a bit. And water's the cheapest ingredient. So in terms of cost, water will be the cheapest, and then your aggregate and then your cement, yeah. You okay?
Is it meant to add up to 100%, or like is there?
Should be 50% water, because I think there's an error there.
Oh, whatever. Just copy these down from my notes, which could have been miscopied down from the lecture slides. Yeah.
Well, what I think should be 50%.
Shut the fuck up. Okay, whatever. Just pretend this adds up to 100%. Hypothetically. Okay. So you might have heard the words paste and mortar. So if you watch the first lecture, this is the first thing to talk about. Did you guys get that?
Yeah.
So I don't think I have to talk about that much. Paste is kind of like used maybe just to patch up a crack in the wall. You would use paste. It's got a lot of adhesive properties, and it's mainly used for aesthetic reasons. Because if there's like a small hole in the wall, you just patch it up, right? It doesn't need to be structural. Mortar, right? Mortar is getting a little bit more structural. So in between bricks, you put some mortar, but it has a little bit more structure to it. It's like dough, right? So if you have like your flour and water and a little bit of egg in the cake analogy, that would be like mortar, right? Okay. Oh, and yeah. Wait, you guys haven't done soil mechanics, right? Oh, sorry. You have.
Just treat it as if he hasn't done.
Okay. What's like an example of a fine aggregate?
Sand.
Sand.
Yeah, okay. So,
Silt. Soil.
in concrete, it'd more be like sand particles. Yeah. What's an example of maybe like a coarse aggregate?
Gravel.
Yeah, like gravels and stuff like that, right?
Minecraft gravel.
Yeah, you can think of it like the Minecraft blocks. And when you're crafting
You
carbon
need
concrete,
gravel.
you need
gravel
sand
to-
and gravel.
Yo!
You need the coarse and the fine aggregate.
Yeah, and then you gotta add water to it, like to hydrate it. Once you get the dry.
We have to make a boral factory next time. Minecraft.
Okay. So OPC, you're gonna hear this term a bunch. This is ordinary Portland cement. This is your modern mix for concrete, basically. They get a bunch of raw materials, namely they will get limestone. This is for making the cement portion. So the important part of the ordinary Portland cement is the fact that this is the cement part of the overall concrete, like, part of the equation, right? Not equation, part of your cake, right? Let's call it. And so the main ingredient is lime. Yeah, when you're making like Portland cement, it's heavily reliant on the fact that you have limestone, right? Which is from a limestone quarry. Yeah, you would dig that out, crush it up. There's all these processes we'll talk about in a second. But yeah, just you can think of if someone just quickly quizzes you like what is cement made out of, you can tell them lime or limestone, right? For geotech, when you do geotech, you learn that limestone is it's like a sedimentary rock, right? And it can be formed. Okay, well, I don't want to overcook the explanation. Okay, you can think of it like it's made up of marine animal like shell debris. So like the shells of sea creatures and stuff like that. That's one way it's made up. But like just if you want to visualize what it is, it's kind of like that. And it's calcium carbonate or whatever it's called. Calcium oxide. It's this thing. It has calcium in it basically, right? Okay. So we use cement notation, right? Which is literally the most tradey thing ever. So here's your actual chemical equation for all of these oxides, right? And we're gonna call these C. I think this one's called F. This one's called S. This one's called A. Right. This one's S hat, and water is called H. Yes.
Do you know in exam, do they do the notation or the oxide like what?
They can quiz you on either, but the takeaway from the course, like the learning outcome, is understanding it in cement notation because that's the industry standard.
That's how you communicate with the trade.
Yeah, basically. Because when we get to more complicated, so these are just kind of the raw minerals and all that, right? When we get to what is inside clinker, there's going to be like alite, belite. In chemical in the regular chemistry notation, these are incredibly long, like chemical things that you spell out. But for alite, for example, in cement notation, it's just 3CS, right? So it shortens 3 of these and 1 of these, right? Together. So it just makes more sense. You break up the smaller things into bigger things and things like that. Okay. Any questions so far? Okay. So, cement production.
This is dry kiln processing.
So, as I was talking about, you have your limestone quarry. You can use your excavator to extract it or whatever they use. It needs to be transported somewhere, right? So, through like trucks. Trucks go into some sort of crusher. So you have your limestone, which is a type of rock. You'll learn about in geotech, right? Sedimentary rock. It gets crushed up into like rough limestone and then crushed again until you get a fine kind of powder limestone, right? Okay, that continues this way, and you're gonna add in sand and clay. So now our mixture's actually changed, kind of like this composition, or it's mixtures change mixture basically, right? So now instead of pure limestone and whatever else was in the raw materials that was extracted from the earth, we've got sand and clay in there as well, right? So I'm gonna do it in orange arrows now to show that the actual mixtures changed, right? And then, during this whole process, once it gets mixed in and crushed up, like it's just constantly mixed, so that it has like this kind of like homogeneous texture. If you're looking at it like from a big enough scale, right? Okay, it goes into a preheat tower. You'll see in the clinkering process, this is the first stage. This is the dehydration stage or whatever it's called. And then it goes through the kiln, right? And this is where clinkering takes place, and we'll talk about this more in a second. But during this process, like chemical reactions and stuff will take place. So again, I'm going to change the arrow notation to purple, right? This is called a dry kiln process, and then you're going to produce clinker as the final result. It looks like this, right? And then the dry process for clinkering, of course, not of course, but like it's the modern standard. They used to use like a wet process, and then Dom tells me that it was called sinter for this kind of wet kiln product instead of clinker. But these are really fun words to say. So that's the most important thing, right? Anyway, we continue this purple arrow. It's changed this whole like, composition. So something else. It's cooled down. The heat is actually recycled into the dry kiln. And this is actually one of the reasons that they use the dry kiln instead. It's in terms of the actual factory like apparatus, it's more like energy efficient. They can suck out that hot air and use it again to power up the kiln. And then it's just more efficient stuff, right? Next you add in gypsum, right? I've got the exact chemical composition of gypsum, but it's what they use in drywall. It has calcium in it. Okay, I don't want to misquote it. Basically, gypsum has a very important. Are you okay? Is it from what I told you before? Okay, basically, cement. When you mix it with water, it flash sets by itself, which is very dangerous. It's like, say you just have like no gypsum in your in your cement, right? And then you pour concrete powder on someone, and then they just walk in the rain. They'll instantly like get turned into concrete essentially, and it's really dangerous, right? That's called flash setting, premature setting, right? So what gypsum does is basically blue balls your concrete for a bit and gives it some time before the chemical reaction actually happens. And this is really important because when you transport concrete that's just been batched to site, you need like 2 hours or so to make sure it can set before it starts setting, because you want it to flow out of your pump and into the formwork and stuff like that, right? So yeah, gypsum blue balls your concrete basically. Okay, and then lastly, now it's blue because we've added in gypsum. It's changed its composition again. proportioned up to here. Yeah, the cement is stored as like a dry powder in like bags. You can buy them from Bunnings or wherever else, and then shipped off when it needs to. Yeah. Does that process make sense? Because that's basically start to finish how it works for cement production. Let's go a bit more into detail for the kiln, because that's probably the most complicated process. A lot of these are really simple processes. It's literally just crushing something up, or like whatever, right? Or
You
adding
use
something.
Minecraft.
Yeah.
It's the
This
whole-
is dropper. This is droppers and fucking pistons, furnace, blast furnace. Well, this is the blast furnace basically. This is the kiln.
We should get like a Minecraft mod, like cement, like the cement.
The
making.
borrow
Borrow
one.
one,
Yeah. So this is just to reiterate, but we have the wet processes, the dry processes. The other problem with the wet process is the kiln itself takes up a longer span. It goes for 200 meters in like roughly, whereas the dry one doesn't need as long. I assume, actually I don't know the reason.
Because you have to dehydrate and then I don't know how. Quit making sure.
Yeah, I think
It
it's,
needs to dehydrate in the wet one, so they need like the extra kiln thing, because they don't like
yeah,
they don't dry beforehand.
It's called sintering, right?
it produces something slightly different. Yeah. And I don't know. All these like advantages to using the dry process. That's the main thing you need to know.
I don't know if
Yeah,
I
the
was the one that's
chemistry.
getting cooked or you're the one that's getting cooked, but I genuinely, watching the first lecture, I don't think sintering came up.
Okay.
I looked it up though. It's a real word.
I know
Yeah,
it's a
yeah.
real word, but I don't think it came up.
I think it did.
Allah whispered it when you were dreaming.
This is, I was looking at it during Henry's 1300 class.
Maybe you just randomly looked it up because Allah told you to.
Because I just remember sitting in that lecture and I feel like I would have known if sintering, because it's such a nice word. I feel like I would
You would have
It's like
flagged up in your
flickering,
ear.
like, it's like flickering. Flickering's flagged for me. Like, why wouldn't sintering flag?
True. Okay. We're gonna continue because we've got just 3 out of 13 pages.
Nice.
Good work.
Okay. We're gonna. Sorry. Do you mind? I'll just keep it zoomed out a little.
Yeah, it's zoom it out, yeah.
Okay. You're gonna see this graph come up a lot. Potentially in your multi-choice like assignment as well, and it could potentially also come up in your finals. You need to know the different zones. So here I've nicely labeled it. Dehydration zone is this first area here. This is where the CO2 escapes as well. There's like a chemical reaction, something along the lines of, this is like the intern version of it, but
Calcium oxide.
okay. It's something like that, right? That's the intern version. I don't know if that's right.
Balanced.
But
It's
you
actually
get it.
balanced.
Actually, it is, yeah. That's not too bad. But yeah, it's called a carbonation reaction, I think. But yeah, it gets rid of the carbonation. It gets rid of the CO2. That's where like you know, in like when people would say that like concrete production is potentially not that environmentally friendly, it comes from the cement production in this exact equation, because that's where CO2 literally escapes from your limestone and then goes into the atmosphere, right? Yep. Okay. Basically, there's going to be a few words that come up here, which are pretty important. Bellite and alite, right? These are the clinker. I want to call them minerals. Let's call them minerals. These are kind of like the products of your clinkering process, right? So bellite happens first, right? It's so basically as we go along these stages, the heat increases. So here, this first one is up to about 500 to 750 degrees, and then in stage 2, around 500 to 900 degrees, that's where you're gonna start. Oh, sorry. It says here 900 to 1350. That's where you're gonna start to see bellite slowly form. So Belite is not as strong as Alite. Alite is actually what you're looking for the majority of the strength of the concrete, right? But at the higher end of the temperature, that's when Alite forms. So I've got a picture, a little like tree diagram underneath, which better highlights all of the differences between Alite and Belite and stuff like that. But yeah, just know that like Alite forms from Belite at a high enough temperature. So we need Belite to form first. Yeah.
But we're looking for allied, right? Is there a way that we can optimize to get more allied?
High temperature or something.
I think you need to gradually increase the temperature because you need Belite to form, which takes time. And then from the Belite you can form the Alite, right? You see how
So just stepwise.
Alite cannibalizes some of the Belite.
Yeah, but how do you cannibalize more of it so you get more allied?
Oh shit, I don't know. I don't know about this specific. You can ask Taewon these questions because he actually knows.
Oh, really?
I think, yeah, he would know about all these because his Taewon's specialization is in cement and kind of like the material science behind concrete, right? He knows about like the site processes, the factory processes really well.
That could be your research thesis.
Yeah, Taewon's the guy for this. For the first part of the course, Taewon knows the most out of all the lecturers at study levels. Yeah. In terms of reinforced concrete, I bet a lot of lecturers know a lot about reinforced concrete, but Taewon knows a lot about the material science part of that. Yeah. I think if someone else who wasn't Taewon took this course, they might not go into as much detail on like the first 2 weeks, to be honest. But it's just because it's his research specialty, he kind of wants to yap about it. Yeah. Because if you do his 4th year course, Max actually is doing his 4th year course. It's called Advanced Materials of Structures or something like that. Yeah, it's about concrete and Okay.
Wait, sorry. What's the fluxing agent
Fluxing agent.
in the melt phase?
Flux makes it not oxidize, right?
I have no idea.
That's what flux
It might
sorry,
be
sorry.
mentioned in my notes.
Yeah.
I'm making shit up.
Oh, you were just bullshitting.
Actually, could be, but I'm pretty sure that's what flux does. Like when they melt down the metal, they put it in so it doesn't oxidize at the top.
Okay, sure. But yeah, I can't confirm or deny that. So you can say anything. Yeah. Anyway, all of these products of in clinker, you're gonna see it in cement notation. So and there's a dead giveaway once you see the S with the hat on it, then you know it instantly it's cement notation, right? There's like a bunch of formulas, which the best way to understand these formulas is literally just to do the workshop questions which involve those formulas. There's a couple listed, and they can be asked in the real exam setting, but like literally only one of all of them will be asked probably in the final exam. Like in terms of what's tested in the finals, there'll be for the material science part of the course, it'll be like very broad but shallow. So they can ask a lot of things, but they won't be very hard questions. But you just do the workshop questions once for each of these types of lab-related questions, and it's fine. But I haven't done it recently, so I can't exactly tell you. But right. It's just to do with the optimal amount of cement to water ratio,
So stupid.
so that everything reacts, and you don't have it's like limiting reagents and stuff in chemistry, basically, right? Yeah.
So you don't
Oh,
have
shit.
bleeding and stuff?
Oh, that's not this part. Bleeding will come in later for concrete durability.
50% water, yeah.
Yeah, so this is all to do with cement hydration. That's just literally means once you add cement and water together, this is what happens. Right. Okay. Okay, well, let's just focus on. Okay, basically, alite and belite, they're called calcium silicates because they're made out of C, which is in trading notation, that's calcium, right? And silicate, which is like SO.
SI.
Yeah, SI, that's right. So, yeah, I'm so bad at chemistry.
Doubles.
I don't know why. This isn't my strength. This part of the course. Like, hopefully in the later weeks I'll do a less shit job. But I'm just trying to run you through my notes and what I've done.
cylinder.
Yeah, basically, there's kind of, so these are the families of the products, right? So alite and belite we've talked about are like related to each other, but you're kind of looking at these. Oh, so sorry. Once they react with water, right? Yeah, alite and belite in the clinker, they can make CH and C-S-H. This is to do with the bonds in the chemistry, but it has a slightly different notation, right? I believe CSH is the end product that you're looking for. That's the strongest thing, right? Yes. Yes. Okay, we'll talk about that graph in a second. You'll also end up producing a tring.
It's like Arjuna's last name.
Oh, yeah.
How do you pronounce it?
Okay, basically, in comparison to alite and belite. Okay. Let's focus on the green part, which says contribution to the strength of concrete. So alite has the strongest contribution. Belite, you can't underestimate the strength that's from belite, because at the start it's weak, but then it gets strong. So it's got a weak early game, but a strong late game. That's good, right? Does that make sense? Yeah. So it will add a lot of strength to concrete later on, and that's why in have you seen the graph of concrete strength over time? It's due to belite becoming fully formed.
Oh, it's the curing, like, is it?
Oh yeah, in the curing process. Yeah. Belite will fully react into these final products basically.
Belite levels up.
Yeah, levels up. It becomes like Nasus at level 18. It's like in TFT, 3-item Caitlyn.
Oh, okay, I get you.
3-star Caitlyn.
Yeah, I get you.
Yeah.
Just understand now.
Yeah.
TFT terms. Okay. Here's the thing. These ones, tricalcium aluminate and tetracalcium alumiferrate, you can think of them as like very similar in terms of the material, the mechanical properties and what they do. But all you need to know, but the forms with different reactions and stuff like that. All you need to know is this is the reason why gypsum has to be added in to begin with. It's to slow down, it's to blue balls these reactions in particular, because these are the fastest. They set the fastest, but obviously you don't want these reactions to set off immediately for the reasons I mentioned before. Like, you don't want the concrete to flash set in the concrete truck, because then it's like impossible to to clean out, right? Yeah, stuff like that. So if you add the right amount of gypsum, you'll time it so that the alite, the belite, and all these things set at the same time, right? And become the product that you want. So it kind of looks like this, right? In terms of the heat, at the start when you mix water and cement, no matter what, you're going to get a lot of heat evolution, but only for a little bit, right? In the first 5 minutes, right? This is a weird graph because it took about minutes, hours, and days. It's almost like logarithmic, right? You'll have about 2 hours from when you add in the water to set your concrete on site to where you need it to be, or ditch it if you can't do that in time. Like, you need to empty out the batch into like a scrap, like a waste site or something. Otherwise, it's impossible to salvage your truck over. Okay, once everything starts happening at once, that's stage 3, according to this particular graph. Which again, you're going to see this graph come up a lot in like multi-choice and then the finals first part. So. And then this is like the accelerating phase, and then there's a decelerating phase, and then in this kind of stage, that's when you're not going to get much additional development of the concrete strength. That's from about say 7 days onwards. You're not going to get that much more strength. Right?
It's the black one. The beginning.
Oh, that's just the
Initial.
yeah, that's just initial concrete reactions which you can't offset no matter how much gypsum you add. Basically, it's just gonna happen.
100% gypsum.
So there will be a 5 minutes of like a heat evolution in terms of exothermic reaction or yeah. Something like that. Okay, any questions so far? Okay, that's a lot of information. We're gonna take Smoko until 2:40. Okay.
Actually, do we get smoker?
Yeah, because otherwise, like you're not gonna be able to take in. Yeah, so I'll switch.
Hopefully, we're allowed to get smoker.
I feel bad for Ashar's transport.
We're mainly having Smoko because I did this.
Oh.
You done?
No, smoker.
Smoker.
Of course.
How's Divya's course so far, Ashara?
Sorry?
How's Divya's course so far?
It's actually not too bad. I'm enjoying it. Are we recording?
It's muted on both ends.
Is it? How do you know?
I don't know.
It's too hard.
Yeah, so
Did you actually stop it?
still recording. It's us in the exec meeting.
Yeah, of course.
Add it on the meeting minutes. We're gonna survive.
Apparently, there's something wrong with PDC marketing.
Huh?
What?
What's wrong?
We gotta change the MRF ASAP.
To what?
I don't know.
Is it gonna make me cry?
Oh no, I don't think so. It's just the prices. It might make you cry. Because we have to change a lot of the current marketing that we have. Can we edit the? We can edit the post, right?
Oh, you need to remind me. Was it Arab?
Arab.
Oh.
Oh, what happened to Arab? No.
No, they responded. They're coming to WIC.
But they don't go to the other fucking things like careers fair or sim.
They really
oh
care
my
about
goodness.
women.
They only care about
I
women.
figured that, since they got back to us within 24 hours and they're so big, it would probably be good for us to have them there.
Wow, wow.
I'll need to edit the type post. The CD.
That is all found. Oh my god. This must cost you a fortune to use.
I have another. No, these are not my expensive fountain pens.
Oh, we went
Yeah.
to Arky and then I was looking at the ink, which is like $100.
$100? What the fuck? This is why people can't afford houses.
No,
Spending $100 on ink.
It's because they had a flash sale where they were because they had a really beautiful fountain pen that I had my eye on. That was at $250.
Oh.
They were willing to give it to you. Like it was free if you spend over $200.
Oh.
Yeah.
So basically you cancel it out. and you
Yeah,
get
right. Your maths. I actually earned $50 from that.
No, you did not earn the money. You just got for free. You didn't earn the money. Oh my goodness.
Yeah, so like, no, you pay $200 and you get a pen that's worth
No, it
$250.
doesn't-
You
no.
earn
And
$50.
you're gonna use the
Yeah.
No,
anyway.
stop that shark. Stop.
Yeah, I actually bought I actually recently bought like a multi-tier like desk organizer to put my inks on. You know, like how you can so I have like rows of inks.
No,
It's like
makes
really
sense.
pretty.
This makes financial sense.
No.
I actually calculated it recently because like
she's gonna use the ink anyway.
my brother sat me down and
She's gonna buy the ink, right? And she's gonna use the ink with her original fountain pen. So why
yeah,
not just
yeah,
a pen
yeah,
for
exactly.
free with
We're
it?
actually on time.
Yeah.
Unlike a borrow truck.
Okay, I'll be honest, we have a lot of slides to go through. I'm not sure if you're going to be able to finish writing your notes if you copy it one
No,
right?
it's okay. I'll just
So you
take
can
your
snap
notes.
photos or you can look at
I'll
the
take a look
recording?
at your, yeah.
it's either recording or it's already uploaded to the
Yeah,
next
okay.
one.
I'll just.
Oh, it's in the
I'll
notes.
just edit it.
This is in the notes. Oh, okay, perfect.
Yeah.
Yeah, that's all good.
Okay, basically, I just want to also reiterate these first 2 weeks have the most material science. That's not my strongest suit. Wait, let me just check. Yeah. Once it gets into like the mechanics, solid mechanics, statics, it'll be less wishy-washy, right? So just bear with me. For
No worries.
Yeah.
We'll be making shit up right now.
Okay, so water in aggregate. This is where week 1 ends and week 2 starts, by the way. Got it? So there's an optimum water level, basically, which, I mean, intuitively makes sense. So if it's too dry, not all of the cement will have reacted, right? And so then you won't get as much strength. And if you add too much, you know those videos with like the rain pouring all over
Oh, the real ascension.
yeah, you're gonna lose strength very quickly,
Pumping
right?
liquid cement.
So there is an optimum water level. This is specifically for the purpose of like strength, but you can compromise the strength a bit for workability reasons. Like say you need to push it through a 50-meter boom pump, whatever. You might need high workability. And there's all kinds of balancing acts that you have to do when mixing concrete, right? Okay, basically, all you need to know, the rule of thumb for water is if you can drink it, if like the water is like drinkable, it's good enough for concrete. I know that sounds dumb, but if you think about it, it makes a lot of sense because it won't have like your chlorides, your sulfites and stuff like that. You won't have these like impurities, right? So generally, yeah, when you're mixing concrete, use potable water.
Just drink it.
The drink test.
Get the intern.
If you don't get E. coli fucking infestation, then you
Pour the concrete.
Wait, why the fuck do they care about sugar? How is there gonna be sugar in the water?
It was a thing. It was a tactic for the French Revolution, like it was like a revolution or something. They put sugar.
What the
You
fuck?
actually,
No, but when
no,
is this
I
gonna happen
noticed.
every day?
No. Like people would actually put sugar in it to sabotage a concrete mixture because they actually can't set if it's sugar.
Oh,
Yeah, it was
shit.
actually an active protest. Like people would actually pour sugar.
Is that something you learned from architecture?
No,
Wait,
no,
so it just
way.
doesn't
But
set.
sugar is expensive though. How do you get all the sugar?
Huh? Well, fuck the government, right? Pour sugar anyway.
Wait, so it just doesn't set at all.
Yeah, you can't set. If
So it's like ED. It's like you get complete ED.
Oh, yeah, true.
It
Yeah.
just would never work.
Okay, so that's basically water. Aggregate, right, is the other part. There's like a few ways to measure aggregate, right? One is size. So we've talked about coarse ag, fine ag, I won't get too much into it. There are official definitions based on like threshold numbers, like 5 mil. But yeah, the other thing is shape. So different kind of like granite that's crushed up will be like rounded, and then gravels will be like a bit more angular, right? So the shape of these particles that you put in concrete will make a difference, because even though it's like a pretty small scale, it'll add up, right? So like workability is better with round particles, kind of intuitively. The cement can like slide between them a bit easier, and angular is better for bonding because it can slide together less, right? So like it bonds together better. That makes sense, right? Okay. There are some definitions for aggregate and the moisture level. As we were walking up from Dom's concrete class, right? He just jokingly said like, why don't we just grab this gravel and sell it to Boral or something like that, right? But it wouldn't work because it needs to have a specific moisture content. It was literally just some random fucking gravel that he found on the ground, right? But like, for it to be useful, you need to know exactly how much water content there is, so you know how much water to add in for that optimum water level, right? There's air dried, so it's on a sunny day, that would be air dried, right? Oven dried, that means there's no water because you boiled out all the water essentially, right? Saturated surface dried would be probably something like a bit more of after a rainy day like this, right? Where the surface is dried, but inside the little voids will still have water. And then completely wet is like submerged particles. Right?
Fully saturated.
Yeah, exactly. And then there's all these formulas here as well. But again, these are moments. You'll have to do, again, like maybe 1 or 2 workshop questions which involve these kind of photos. This is a part of soil mechanics. Sieve sizes. Kind of makes sense. So maybe if you're baking, you have like these different sieves, right, of different finenesses. And so if you want to like aerate your flour or whatever it's called to make it a bit more of a fluffier cake, anyway, point is sieve sizes, just understand that concept. It can filter out various particle sizes. There's durability issues. So when you're talking about durability issues, think about like a diamond sword in Minecraft, right? Durability is the ability for something to last over time. And so for concrete, and just structures in general, you kind of want things to last for like 100 years, like or more. You're designing them to last. And then there's all these kind of like chemical processes, chemical attack that can happen to make it break faster, right? This is like unbreaking -3. You know what I mean? Okay, anyway. There's a term, this is kind of a fun word, so I'll just highlight it. Concrete cancer.
Yeah.
Concrete cancer is due to these reactions. There's alkali silica and alkali aggregate reactions.
Wasn't like another word for it? It was like something like not molding. It's like
Oh, scalding?
spalding, yeah, not
That's
molding.
that's due to fire. So even though I think it's scalding.
Well,
I could be thinking of something else.
I think I might be thinking of something else.
Sorry, you can Google it.
Okay.
I'm pretty sure spalding is when it's fire damage caused on hardened concrete. Because like yeah, you know how like steel melts in the face of fire? Concrete will spald basically. It just damages the surface. And like construction integrity.
Super hot fire.
In general, concrete is better than timber and steel against fire damage, but it can still get damaged, and then that damage is called spalding. I'm pretty sure it's spalding, but I could be mistaken.
Okay, I was thinking of a different thing for concrete cancer, and then spalding is, I think it's correct.
Okay, I think I'm thinking of the wrong word.
Spalding?
Oh, is that what? Spalding.
I was thinking of spalding.
Oh,
It doesn't matter.
okay. So, mineral admixtures. So we've jumped to topic 3, but I'm doing 3C because again, this is still like chemistry related, right? So, admixtures are also called supplementary cementitious materials. So if you see SCMs, that's like a synonym for admixtures. So basically, let's go back to the cake analogy. Your regular cake might be made up of eggs, flour, water, right? Maybe milk or something. That's your OPC. So you can choose to change up the base of this recipe a little bit. You can add, I bet you can use like mayonnaise for like eggs in like cake because it has like a bit of egg or whatever, and it has like kind of cake. Yeah.
I bet you can use Coke.
Coca-Cola.
Coca-Cola.
Cocaine.
no, instead of like baking soda or something like that.
Sure.
Oh,
These are all
Adding wheat.
like
Yeah.
ingredient replacements. These are SCMs. So you're gonna make a different type of cake. But like they might be advantageous in certain ways, right? So basically, your OPC, your Portland cement, is gonna undergo something called a hydraulic reaction. That's everything we've talked about so far: limestone, clay, gypsum, that kind of stuff. A pozzolanic reaction comes from adding these kind of funky ingredients, right? It comes from mostly volcanic rock. So fly ash. Okay, well, fly ash I'm pretty sure is from pulverized coal. Yes, and then but like. Okay, anyway, let's not get into it because I haven't researched this fully, right? Basically, you just need to know the chemical reaction. It can be gauged on a kind of linear scale. So on one end, you might have a hydraulic type of reaction. That's like OPCs. Imagine. Oh, try that door.
Is he doing concrete?
Yeah. Hello.
Yo, my stuff ended early, so I was wondering if you guys needed stuff help to like move stuff down.
Oh yeah, no, all good. We don't need it yet. Yeah.
Super
You
fast.
sit for the concrete stuff. We're gonna go for 10 more minutes. Okay, so on one end, hydraulic reactions, that's OPC. On the other end, you have your pozzolanic reactions, basically. Okay. Okay, basically fly ash is from coal fire power plants. So these are usually byproducts. These ingredients are taken from other industries. So in power plants which use coal, they get the remains and then they can make fly ash from that.
They also have cremation.
Oh really? Fly ash. Oh shit. Okay, well there you go.
Where is it?
There's a bunch of stuff. They probably wouldn't get someone's cremated ashes and put it into cement, but who knows, right? Yeah, and then there's different classes of fly ash. So there's class F, Class C, yeah, you can read the pros and cons. Blah, blah, blah. The slag, or this is also called ground granulated blast furnace slag, GGBFS, right? Okay, this one isn't a pozzolanic reaction, but it gives a latent hydraulic reaction, which, okay, I don't know what that is.
Thank you.
Silica flume. Okay, basically, silica flume. This is the most pozzolanic. This is a purely pozzolanic material, right? So this will give the most extreme, different type of cement mixture that you can get, and it's used for ultra high strength concrete. So it's UHSC, I think it's called. And its properties are generally quite different. It will be more expensive. It will be much stronger. It's used for high strength concrete. Much more durable, but yeah, trade-offs for everything, right? And then here we go. So this is a really good diagram. Over here, OPC is the most, again, if you think of it like a linear scale, OPC is the most hydraulic in terms of its reaction, and it's due to that that line, right? And then silica fume is as pozzolanic as you can get, and then all this other stuff kind of is a linear scale. And here's another, there's many ways to classify what I've just said on different scales. Yeah, pozzolanic, OPC. I mean, this is just, it says cement, but this means OPC, cement, right?
Is this week 1?
Week 2. You're not good. It's okay.
Week 2, like the other half, right?
Yes.
Okay.
I've actually jumped forward and then I jumped back because I'm just grouping the chemistry together.
Yeah.
So here's back to CVAM 2101 construction, yeah? This is fresh concrete.
I understand this so much easier.
This one I'm going to run over fairly quick because you guys already done 201 and it should make a good amount of sense, right? You have batching, mixing, transporting, consolidation, finishing, curing, and formwork removal. So the general process to pour concrete is you set up formwork. The chippies set up formwork. That's like another word for a carpenter, right? They work with the timber and they'll lay out the kind of shell which the concrete will be poured in, and then you get the steel fixers in. The steel fixers will, actually I might pull this up. Your formwork might look like this with its supports, right? That's made out of wood, and that's the ground surface. And then the steel fixers will set up these kind of like chairs, which is made out of plastic. They're a sacrificial kind of way to elevate the steel, but it's going to be poured over essentially. It's just so that the steel's not too far, not too close to the edge of the concrete, because otherwise there'll be durability issues. When steel is in contact with like the air, stuff like that, you get oxidation. Yeah, corrosion. stuff like
Concrete
that.
cancer.
Not quite.
Not that.
That concrete cancer is due to like
Oh, there's a thing with concrete.
alkali
Alkali.
or whatever it's called. Anyway, get your rebar in. Normally get your axial bars in first. So during a cross section, these chairs they'll sit. Oh, sorry, the rebar will sit on that, right? And then you'll slip over your shear bars, which you'll learn about as well. So say it looks like that. There's axial bars. So all the axial bars get put on first, and then you put your. There's actually a few words for it. You'll learn this more in week 7. Stirrups, ligatures, shear bars. That's this kind of like rectangular shaped thing that forms the cage. And then you get your closing shear bar, that. And then it'll look like a skeleton, right? This is all made out of steel. And then you pour the concrete in, like that. That happens on a pour day where everything happens in the span of 4 hours, right? And then from the point where the concrete gets batched by Boral, the on site has to happen all within like 2 hours or so. Okay. And then the formwork gets removed once the concrete is set. So you do all the curing and stuff as well, whatever. So that's all set now. You remove the formwork. That generally is how it goes. And the steel, of course, stays inside the concrete. That's how you make reinforced concrete. There's just like a few different placement methods. The pump is for when it's like hard to reach. Okay, you know what? I'm not gonna go over this stuff. The chute is basically directly from the truck's mouth. There's like a little chute that shits out the concrete basically. That's the most like basic method. That's when you have good access with the truck to the former. Okay. Yeah, you need a vibrate concrete to pop all the air bubbles. Actually, Dom covered this pretty well in his 201 crash course. Yeah, this is less strong when you have a bunch of air bubbles, right? Because you drop the concrete and then naturally it might just have air bubbles and pockets because you moved it.
It's like a cake. You gotta like vibrate the cake in
Yeah.
order to get the air bubbles
Exactly.
out. Otherwise, it's gonna crack when baking.
Perfect. No, literally, like, imagine, because you know how you have to put your cake batter in the oven and cook it,
Yeah.
and then it becomes like all solid, right?
No.
That's basically concrete, except concrete's chemical reaction happens outside of an oven. It just naturally heats up once all of those reactions hit, and after the gypsum delays that setting for the other, like, so for the other minerals, yeah. Alite and Belite, yeah. Okay, cool. And finishing is just to make sure it looks nice.
Icing the cake.
Yes.
With a trowel.
Pretty much. Yeah, pretty much. It's just to make it look nice and stuff. Okay.
Serve some mixed cakes and some cows.
And if a cake like gets too dry at the top, it'll start cracking as well, right? Actually, I don't know much about baking. I'm not talking about baking analogies.
Sure.
Okay, yeah, sure. Okay. Is there anything? Fresh concrete. We've talked about this. Let's talk about this. Segregation and bleeding. Actually, I have a diagram for that below.
Segregation.
Okay, maybe we'll just quickly talk about the workability. For stuff like pavements, generally it's advantageous to have a low workability just because it'll be stronger. But you need, like, when you have pumped concrete, straight away you need a pretty high workability or it's not going to go through the pump, essentially. So yeah.
What were those numbers next to like the factors? Remember? Because this is yeah.
Oh, these are the slump amounts. Yeah.
Oh, but there's also like factors in the slides. So you need to know those.
I'll look it up right after we're done.
I
I
saw
think.
some and I'm like, what?
Because I haven't seen that graph, at least not recently. Okay, basically, these two are concrete defect types, segregation and bleeding. They look different, but they're caused by all of these things. Too much water, over vibration, incorrect use of admixtures. Yeah, just like, oh, actually it's funny, because back when I went to CBD, right, I looked at a training module made by like Transport New South Wales, and the first thing they said was, good concrete is made up of aggregate, water, and cement. Bad concrete is made up of water, aggregate, and cement. So it's the same shit, but so much can go wrong if you fuck up any of these steps. So same thing with a cake. Even if you have the right ingredients, your ratios are wrong, you don't mix it enough, you put it in the oven too long, all these things. It's just like fucking making a cake, basically, right? Yeah. Anyway, segregation and bleeding. Segregation is where your fine aggregate goes to the top and your heavy aggregate or your big aggregates will fall to the bottom. Bleeding is where the water seeps up to the top and then you have the wrong, it's not homogeneous anymore, basically. You have the wrong like ratio of water and other stuff. Plastic cracking, right? Obviously this is cracking, but this is specifically cracking in the fresh concrete stage. When it becomes hardened concrete and it starts cracking, that's called dry cracking. So it's just classifying the cracking based on the stage at which it happens during the concrete's lifetime. So this is why you cure it to avoid plastic cracking. That's where it evaporates too much at the surface, right? Yeah, so this is a pretty nice graph, right? So basically, the concrete's curing depends on mainly three things here: your moisture content, the temperature, and time. Okay, basically the most, probably the least intuitive is temperature. Basically, even a small increase in temperature outside will affect the evaporation rate at the surface, even a little bit. And I guess you can think of it like when you're drying laundry on your balcony, right? Yeah. like even a small temperature increase or whatever from outside will change how fast your clothes will dry, right? It might not be at like boiling temperatures or anything like or anything close to that, but yeah, a small temperature difference will make a difference. So yeah, so and then when you cure the concrete, it's really important for its concrete strength, just because if you don't cure it long enough, it's not going to be able to go through all its reactions properly, like its chemical reactions due to all the previous reactions I was talking about. Yes. Okay. You know what? I might talk about hardened concrete next time because this is where we start getting into mechanical properties. So I figure this is a good point to break it off. Do you see why I put 3C before 3A and B? So this kind of groups well and nicely with the week 3 content. Okay.
Thank you.
All good. Alright, I'm gonna stop recording.
Hey, no passing.